Hi, welcome to this presentation on how we at Unity have been scaling our DevSecOps tooling to more than 100 deployments per day. Thanks for joining. This is not just a minute. Yes. So as most of you should be aware, when working with security, it's a constantly moving target. I've illustrated this given from a game company with a tower defense game. So in a tower defense game, you typically have lots of different enemies, threats coming. Which strategy you choose to choose for defending this can vary, most likely different from mine. But the intention here, or the idea, is to show that we have a lot of different tools to choose from, and also the different threats we are facing also changing over time. A bit about me. My name is Rasmus. I've been working for Unity since 2013 in different parts of the company. Come a bit back to what Unity, our game engine and our services. Been working as a lead engineer for our DevOps team since 2018, or one of the DevOps teams. And otherwise, my background has been as a developer, working with test automation and also leading QA teams. And especially, I'll say my background from working with the QA, I see similarities between how QA was organized like 5-10 years back. Would you have this as part of a software development lifecycle, that you have these at the end of the development, you have a testing phase where you would have have time for doing manual testing. And I see a similarity between how we actually treat security these days, where if we want to develop fast, iterate, develop quickly and deliver quickly, there's no time also for either manual QA or a rigorous security audit. So I see similarities that way of how to actually get that also security testing and tooling closer to development workflow. And feel free to contact me on the email address rasmus@unity. Why is it doing this again? Yes. Briefly about how what we do at Unity. So most of you might be familiar with Unity as developing a game engine and editor for building games, which looks like this. However, in the world of today, building a game is not enough to actually build a successful business on games. So for which Unity also has moved into building the services, which are sort of these post-release, operating your games post-release. And one of those is the ad network, originally founded in Helsinki and now spread also to San Francisco and other offices, with the intention of helping game developers to actually how to build a business on their games. So, and that also ranges for advertisers to actually for the advertisers to reach out to new audiences, which is also a part of when you build a game, how to actually reach out and let the world know about your new awesome game. So, but of course, this also poses some challenges. So from technical side, so in our case, we see roughly around 35,000 requests per second from games requesting an ad. From roughly, we see 1.9 billion unique devices on a monthly basis. And we have developed a architecture of 200 microservices for dealing with this, which of course brings some interesting challenges, both in terms of handling the scale of this. We have some of our microservices running more than 1,000 Kubernetes pods. And also, as mentioned, the scale of deployments, where we on busy days are deploying doing more than 100 deployments per day. And back to which actually this is number of our deployments from last week. We have one of our Grafana dashboards actually do show number of deployments, and also a theme throughout this presentation is also how we're actually utilizing having a shared build pipeline, which, for instance, can give us information about number of deployments over a week. And in this case, you can also see that back to the point of us being spread geographically across Europe and US, there's actually not really any quiet times except for weekends, and even you can see the weekends this weekend. There's even been a few deployments over the weekend, which also means that our infrastructure for running deployments and our build pipelines needs to be fairly reliable, and not even have time for maintenance windows for that. And yeah, we actually, so on average, we've been a bit lower than 100 deployments per day, even though I promised that in the title. But due to the Corona situation, people are working from home, and we even actually see a bit more traffic. Obviously, now people are spending more time at home. So I'd like to borrow this slide from a presentation by Guy Bodjani from SNCC. Actually a good presentation, 3 phases of DevSecOps. Recommend you see that. But he talks about the monolith versus microservices. Whereas in a monolith, you have this clear perimeter of the system with relatively few inputs and outputs from the system. And what happens within that sort of black box is, from a security point of view, not that interesting. Because as an attacker, you have the external interfaces to the system. And if those are limited, as in a monolith, it makes the challenge or the task simpler from a security point of view on how to actually analyze and do audits on this. And there's also these more constrained flows within, going back to that you have limited number of ways that data can flow through the system. And also the deployment of a monolith is more like you have this huge box, and there's actually a bit more time in that to do a security audit, for instance. Whereas on the other side, he says having the microservice architecture, which has, from a security point of view, a lot more variables and combinations in terms of how data can flow through the system, interfaces into different microservices, and also having a lot more deployments going on typically. One of the advantages of using microservices. And even he goes as far as calling a microservices a mess from a security perspective, which I do see the challenges. I'll get back to on next slide on why we actually, given this, have chosen a microservice architecture at Unity. And also, but I'll just add a bit more thoughts on this. Some of the other things we see, of course, with the microservices architecture is that you have what I would call a library duplication. So you actually see that the same libraries are being used across multiple code bases. So just in practice, if there's an update or vulnerability in one library, you need to be able to detect that and patch that across all the different microservices where that library is being used. Whereas the task is a bit simpler in a monolith. And basically then having more moving parts within a microservices architecture, as well as a lot of different ways that those microservices can communicate. In our case, we even have some microservices are communicating directly using HTTP. Some of them will communicate via some pops-up messaging system, events, etc. Yes. So with this said about the challenges we impose on ourselves while choosing a microservices architecture. So why is it actually we've done that? And interestingly enough, the delivery backend for our ad network actually did, as I believe most successful software products in this world, did actually start out as being a monolith. However, that does cause some other challenges in terms of how do you actually scale a monolith. If you have this single unit of scale where you can, if you need to scale up, for instance, the delivery part, the APIs for that, if you have a monolith, you don't fully use your resources optimally if you, as part of this scaling one part of the system, also is forced to scale the other parts, which in most cases are receiving less traffic. Another part is when we, as the engineering teams or development teams, has our role of supporting business growth. And one way of doing that is, or the typical way is to release features more frequently, and actually that way also verify that yes, this meets the requirements from the customers. And mention back to the ownership or the in a geographically distributed development environment, having one monolith code base does, at least in our case, did cause some challenges in terms of how to collaborate effectively across time zones on a code base. And having separate code bases as part of microservices architecture does help on how to actually more clearly define the ownership of services as well as code bases. And just on the right side, the diagram, actually one of our internal tools called Dependency Mapper, which shows the dependency graph from, is not part of one request, but it's the dependencies between services. Some of them will communicate asynchronously via messages. Some of them will be direct HTTP calls. A bit about DevOps culture and also how that fits into when you look at the security and the DevSecOps implementation. The DevOps team in Unity Ads, we are 7 people across Helsinki and San Francisco. And in total, the engineering organization for Unity Ads is 220 engineers. So from the beginning, when we formed the DevOps team, we've seen it as our role to avoid becoming a bottleneck. And when you are a small team, it's very easy to become a bottleneck if you, or if you're a centralized team, I would rather put it. If you're a centralized team, as a DevOps team often is, it's very easy to become a bottleneck by requiring, for instance, all development of the CI pipeline could be that it would only be developed by the DevOps team. But the approach for that in our case has actually been that to see us more as a maintainer in the open source sense, that we keep track of, for instance, some of the libraries, the shared libraries being used, our CI/CD pipeline, but in most cases, whenever possible, actually let the dev teams themselves implement features, and we more have this maintainer role of reviewing pull requests to the shared libraries. So we actually recently, I believe a month back in the Helsinki office, we invited all dev teams for pizza. That's a good way to get people to show up. And basically, so I had a small retrospective on how is the DevOps culture in the organization. And some of the feedback we got was that actually, yes, in the DevOps team, we do facilitate shared learnings across teams. And that's also seen as expectation to the DevOps team on making sure that learning from one team, best practices for one team is actually spread either via tooling or just communication to other teams. Related, being an awareness center, empowering teams through transparent tooling, which also means that teams can actually easily dive into our common build pipeline, our deployment tools, and see what's going on. And that's also been the intention from the beginning, not to have this as a black box. and standardized tooling. And the reason for bringing this up is also when talking about security, we also get a role in DevOps team of facilitating or connecting with also security team. So we do have a centralized security team across Unity, a global security team, who are taking decisions on some of the security toolings to use across the whole company. And how do you actually then integrate best with those tools, and also in the most seamless way, so development teams will actually take those tools into use. Quickly about our sort of component ownership, I call it this case. So at the bottom level, we have shared infrastructure. So we're running on the Google Cloud. Of course, we have a shared network monitoring, but also security tooling, as mentioned. So our security team has taken decisions on some security tools to use on the global company scale, and then how to actually best integrate into those. Then we have our common CI/CD pipeline, which will also be as mentioned, a topic throughout this presentation, because that actually, by having a common pipeline used for all services, that enables us to have a single point where we can integrate new features and make that available to all teams. Then we have some shared libraries, Terraform modules, and then at the top we have the dev teams themselves actually owning how they want to run services, which databases they choose to run on, and they sort of find this best balance of how to enable the autonomy for teams to decide themselves how to run, but still taking advantage of some shared ownership of. So if one team is developing a monitoring library or improving, could be also improving security tooling, how to get that spread to all teams. We've been inspired by this blog post from Kubernetes on 11 ways not to get hacked. It has some good pointers. Briefly go through some of those. First one says, or one of them says, statically analyze YAML. In this case, obviously, Kubernetes manifests, but we actually have extended that to just general static analysis. Whenever you can do some linting, it's a good way to provide early feedback to developers on potential security problems. Not a good practice. If you have seen some of the previous presentations, there was a SNCC earlier this morning. Avoid running containers as root when possible, and there's also some tooling for that. And in the SNCC presentation, there was actually an example of how basically, so you can have access to just within the container, if you're running as root, can have access to the file system on that if you're using a vulnerable library. Then, of course, image scanning and run intrusion detection to identify any issues in production of actually malicious behavior from any containers. And the blog post also mentions shift left as a way to get feedback as early as possible in the development lifecycle. Again, back to the point of we want to be able to release fast and not have to wait for security audit at the end. And also with the purpose of decentralizing security tooling, and instead of having a centralized security team only taking care of owning the security, spreading that ownership and awareness all the way down to development teams. Let's look at then at DevSecOps workflow, as I call it. So it's basically just as such, it's just the usual workflow. So we have at the left side, we have development. Then we have in the middle, we have what is covered by the CI/CD pipeline. build and test, static analysis, deployment, very simple way. And then at the right side, when we actually have our system in our software running in staging and production. In our case, using Kubernetes, could also be other ways. But such it's so typically the middle part, the CI/CD pipeline, will be where the DevOps team owns. But also seeing this as a DevSecOps workflow is actually also extending that from all the way from development and to running your software in production. And I'll go through doing this presentation some of the tools we actually use for this, where we call the part in the development phase is more like how do we actually keep the code base tidy and give early feedback. We don't have any standardized tools for security tools using build or tests. Some development teams are using, for instance, part of unit tests, but no standardized tools for this. But we have doing the static analysis, running a few tools, and again that's with the intention of at least doing build, getting feedback if there's any potential problems in the code base or the dependencies used. And then as part of deployment, sequence management is also an important part of again scaling the ability for development teams to easily apply best practices. In this case, not to have any secrets stored in the code bases or in our code bases. And then doing staging production, runtime scanning tools, which verifies that yes, containers are running as expected. And also to find, given that we're back to the moving parts in this field, that vulnerabilities can actually happen even outside. So you could have a service which is not frequently deployed, could have been deployed last time 2 months ago, but there could still be found from external side vulnerabilities, for instance, for some of the libraries used in that. And in general, if you look from the left, it's about, so the further left, the tools is about providing early feedback to developers, to development teams. And further on the right side is more on collecting metrics related to security for security team, for a centralized security team, and also for us in the DevOps team to act on. But such, ideally, we want to push everything as much as possible, early as possible in the development flow lifecycle. We'll look first at how to provide early feedback. Just a brief reminder. So lots of those examples. Equifax is probably the most prominent one of a data breach affecting, as we call, more than 100 million users' data. But as such, it was the root cause of this was a unpatched library in one of their services, which had been available. So the patch had been available for 2 months at that time when the attackers actually took advantage of that vulnerability. And one tool that we use for this is Renovate, which basically will update or will create a pull request into the repository whenever it finds a vulnerable library or even the update library. And I say that's a good example of how to get, if we talk about getting early feedback and getting a smooth experience for development teams. I say being able to automatically create the pull request directly in the repository, and then for someone from the development team approving that. And even in some cases, so for a pull request, we also go through the normal CI pipeline. So you also even have that. So you would actually, so in case there would be anything breaking from that pull request, it will also be detected automatically. But I think that's a example of how to get feedback as early as possible, and even in an actionable way for the development team. So that is sort of the ideal for how the security tools should work. Another part of early feedback is to keep secrets out of code. And Uber had a example where they leaked a public repository gist with a access token to AWS, as we call it. Again, causing millions of drivers' information being leaked in that case. For that, we actually have a internally developed tool at Unity, which will basically, whenever you push a secret to source code, will detect that and provide feedback on the commit itself that, hey, please check this, and means that, and also the security team will get notified in that case. For both Renovate and these tools, there actually are, of course, alternatives. I know that especially GitHub is ramping up on this. So GitHub actually does have a token scanning tool, which does the same as this. And another aspect of security when we're talking about the build pipeline is actually when to trigger the CI/CD pipeline. So it's basically this step when you go from development into deploying the software to production. And good practice is only to let the CI/CD pipeline have access to deploy to production. So no manual deployments directly from development machines, simply with the point of, or the intention of, being able to answer the question of what is running in production. If you know that everything goes through your CI/CD pipeline, then you will know that what is running in production. You have the paper trail back to actually figure out how was it deployed, where does it originate from. But our case, only deploying or starting the build pipeline when there's been merged to master from pull request, which has been approved by at least one other person from the team. So no direct pushes to master, and as mentioned, only our CI/CD pipeline actually have access even to deploy to production. Static analysis tools. So with the intention of providing, it's not as early feedback as, for instance, Renovate, which would basically go in and doing development, update the tools. But static analysis is part of the build pipeline, quite classic way to detect if there's any issues in either source code or libraries. Let's take a look at those we're using. SonarQube. I would actually, we started using SonarQube as more like a quality tool, given that it has actually a ability to provide information about code smells, code duplication, but also being used up by our security team, given that it has these security hotspots. So basically, the intention here is to get, so security team can also use this as part of a more like ongoing audit of a service. And the SonarQube is then one of the sort of sources of information for the security team as part of their review. So they're also interested in as many teams integrating SonarQube and some of the other tools, even in the case that the team themselves might not react to the findings, then it's still valuable information for a centralized security team to know where to actually go and find these security hotspots. SonarQube has a nice integration to GitHub, which is this one. So basically shows checks on the pull request level on any findings from that pull request. Then another tool which we're using is SourceClear. As actually, I saw the SNCC presentation earlier this morning. Looks very similar. I've also heard SNCC mentioned from our security team. We've been using SourceClear for something like 2 years. we're in the, say, constantly also evaluating tools. But at least SourceClear is what we're using for now, and similar to SNCC and other tools, provides information about vulnerable libraries in your code, anything to react on, and the way it also gives an overview of our entire code bases across services. And this, of course, is the sort of ideal view for service. In this case, it's actually a service using, so 61 is the number of libraries being used in this service, and 6 is the number of licenses of a unique licenses used by libraries from this for this service. And I say the licenses part, especially when we can compare with Renovate, because Renovate sort of solves the same task of identifying if there are any dependencies which need to be updated, and Renovate does it in the sort of the from a feedback point of view. Renovate solves that by actually making the change in a pull request. SourceClear in this case is more reactive, and so is run as part of the build pipeline. But at least one difference between those is this ability to also scan for licenses, which is used by our legal team to actually know, are there any licenses, and especially risky licenses like GPL being used in our source code. However, SourceClear does not have directly the same integration into GitHub as SonarQube had. So we have had to integrate or build that integration ourselves into our pipeline. And that's another example of, coming back to the point of having a standardized common build pipeline, actually enables us to implement integration, for instance, for SourceClear once, and then it's available to all services and development teams. In our case, we're using Jenkins, and Jenkins has this notion of shared libraries, which allows you to have a common sort of keep your logic for the pipeline in one place and then reuse that across repositories. And even if you're using whichever CI/CD system being used, if there's ability to somehow use include statements, shared libraries, say that's a good, from our learning, that's been a good way to ensure that we get the best practices shared across teams using this tooling. And quickly show, so that means that in practice, on a repository, you will write in the Jenkins file. The Jenkins file itself is as such just configuration for the build pipeline, and the source code in the shared library, in the Jenkins shared library in this case, then we'll look at the configuration, in this case the SourceClear option, and the dev teams has ability to, so in this case SourceClear needs to know what programming language has been used. So in this case it's a Java, OpenJDK, and so get that image. So we also in our build pipeline running these steps using the Docker, which means that we don't need to have all the development tools and SDKs installed on the Jenkins workers, but run those in Docker. And this case is just a matter of running then SourceClear from Gradle. SourceClear has a Gradle integration, at least for Java projects. And then this process SourceClear log method, which basically will pass the output from the SourceClear. And in this case, the team has actually requested to get notifications if there are any high risks found in that project. How it looks from in our Jenkins pipeline when that runs, quite classic with the build and static analysis and going to deployment. So the SourceClear step in this case runs, is available, but also the sort of disadvantage of this is that it can be hidden from the development team, and especially that they need to go to a different system, which is why we have integrated. So basically the Jenkins pipeline will be able to push or comment on the pull request and sending information back on the pull request, which again is a matter of getting integrated into the workflow of development teams. And one feedback was basically also as part of avoiding a huge wall of text to make it expandable. So that's the default view that the development teams will see in their pull request, but then allowing them to actually see more information. And you might also say some numbers here. So you see in this case, we actually see that often. So 95% of this service is actually consists of third-party code, which is consistent with also Snick presentation this morning mentioned that yes, most of services, he mentioned a number like 90%. So that's also consistent with that. Well, otherwise, getting information about the number of vulnerabilities and the list at the bottom of which vulnerabilities were found. In this case, this is a Java service of roughly 40,000 lines of code, which takes 30 seconds to run scan for. So say the tools also are fairly fast. And that's one of the advantages again of microservices is actually that it allows us to integrate these tools because on a smaller code base, they can actually run fairly fast. Then we have experimented with Trivy for scanning open source images. No, that's not well. Okay, Trivy is an open source image scanning tool. Experimented with that for scanning images. As such, the information it provides back, again, integrated into development workflow of providing feedback on the pull request. We'll give information about are there any vulnerabilities associated to this Docker, to the produced Docker image. However, the feedback from teams has been that yes, this is interesting, but typically Docker files are fairly static in the way that if Trivy finds an issue, it's not because of some change that was made in that pull request. It's more like, then we're back to the external dependencies or the moving parts. It's more like it's typically caused by something else has changed, that a vulnerability was found. So it's actually not, so the information is not relevant on the pull request itself. So that's where we are more using centralized tools for actually identifying these. But as such, it provides good information and is a tool set free. So it is, and it's fairly easy to implement and take into use. Then from secret management, and we're back to the point of keep your secrets separate from codebase. Avoid having any secrets in your codebase. In our case, we've been using Vault from HashiCorp for this. There are other tools exist for this, obviously. I say the reason for us, and there's, I know that a few months back, Google announced their secret manager for Google Cloud. I say one of the reasons for us to use Vault has been that that was available at that time. There might most likely be other alternatives. But in our case, even our security team have actually written a blog post about how our secret management work across Unity and using the secret Vault secret fetcher tool. How it works in practice is that, so this is an example of a Kubernetes manifest. So instead of either writing the secret directly or using the Kubernetes secrets, this will fetch the secret from Vault. The advantage of that is that Vault actually allows that secrets are write-only for developers, and only the Vault secret fetcher can actually read them. Whereas if using Kubernetes secrets, for instance, if someone gets access to a Kubernetes cluster, they can also read the secrets. In this case, by having the even decoupled from Kubernetes means that it's more safe from that point of view. And another feature is that the vault secret fetcher actually works in a way so it does not pass any environment variables to the container, but it fetches them while running as part of the startup of the container. Last part, when actually running our services in production, how to do runtime security scanning of those. And there we have, say, StackRox is a recent tool that's been taken into use by our security team. I don't have that much information on it yet. Whereas we have also been looking at Falco. That's actually been in the DevOps team ourselves. We worked on that just to basically it was a bit out of just curiosity to see what information can we actually get about containers running in production and anything about how they behave. Back to the Kubernetes blog post about not to get hacked. One of the mentions is run containers as non-root users. And this is an example of where we can use these runtime scanning tools to identify issues like that. Falco is one of these tools, available open source, and based by defining rules, and comes with a lot of rules out of the box. One of them is for detecting, in this case, containers running as root in your cluster. And example of how that actually looks when being triggered. So this, in our case, we integrated into Slack. So we get a notification in the Slack channel when there. So in this case, IP masquerade agent running as root back last autumn, so some time ago, luckily. But also, I say this also shows the challenge of, and the feedback was from dev teams that a development team cannot really use this information themselves. So this is an example of some information that goes to either us in the DevOps team or a centralized security team where they actually can get alerts on these cases. But because it's not something that the development team themselves necessarily, if a container starts to behave in a malicious way, is not something that the development team necessarily are able to react on. So that's some information that actually needs to go to a security team instead. Lastly, about learnings. So in our case, I say one of the big learnings is this, that having the standardized CI/CD pipeline allows us to integrate security tools and spread that across all teams. And even in the cases where teams are not necessarily reacting on it or even not getting notified, the fact of having them integrated into, for instance, tools like SonarQube or SourceClear means that we, from a central point of view, does actually get a better overview of what is the state of our code base. And then I'll say that it's not about as much which tools you pick, but more like have a focus on early and actionable feedback for dev teams if you actually want to scale, in order to scale best security practices across a large organization. And of course, feel free to reach out if there's anything. And otherwise, so what time is it? It's 59. No questions on Slido unless someone wants to post now. But otherwise, thanks for listening and enjoy the rest of the conference.